Okay, question D, the largest value achieved by 3 cos squared x plus 2 sin x plus 1 equals how many? Okay, I suppose we've seen this lots of times at this point, right? I mean, in previous papers, this also exists. Yeah, lots of trig and quadratics. And the trick is always to complete the square. Right, to complete the square, and then you go from there. All right, so you're probably getting tired of this, but let me go for it. So the classic, right? First of all, you use the identity because the term in the middle is sin x, right? So you've got to get a quadratic term, which is sin squared x instead of cos squared x. So I apply the identity. All right, so that's this plus 1. Okay, which equals negative 3 sin squared x plus 2 sin x, and then plus 4. Happy so far, yeah? And then I'm going to complete the square from there. All right, I'm going to complete the square from there. So you know this is a negative quadratic, right? So maybe if it's unpleasant to complete the square, yeah, you could also differentiate. All right, you could also differentiate because completing the square might be trouble here, right? Although I mean it's not too bad actually, because you get sine squared, something along these lines, and then you know the constant might be hard to find or something, right? Okay, so if you don't want to complete the square, you can also differentiate, all right? But remember, when you differentiate, you're not using the chain rule to differentiate at all, all right? You're differentiating something like, let's use apples. So negative 3 apple squared plus 2 apple plus 4. You're differentiating this, right? Because what you're interested in is what the value of sin x is. Yeah? You're interested in what the value of the apple is. You're not interested in the value of x. Remember, you're interested in the value of sin x, okay? So therefore, when you differentiate, you could treat sin x as apples. All right, and then you differentiate from here. So negative 6 apple plus 2 equals to 0, right? You're trying to find maximum, so apple is 1/3. All right, so and then you will sub in 1/3 into the original expression, and then you'll find out what it is, right? Okay, word of warning though. If this apple was, for example, like 4/3 today, then you got to be careful. Right, because sin x cannot be 4/3, right? 4/3 is unattainable. All right, if you get a value which is unattainable, right, then you got to think carefully. What you normally would do is you find a value which is closest to that, most of the time. All right, there's some exceptions, but most of the time, you find a value closest to it, then you get the largest value. All right, for example, if you get 4/3 for your apple today, then you got to pick sin x as 1 instead, right? That's the closest value which is achievable. That closest value to 4/3, which is achievable by the sin x. All right, so be careful there. But today you're lucky because the 1/3 is within range. All right, so then we could sub in 1/3. Then we'll get negative 3 1/3 squared plus 2 times 1/3 plus 4. Okay, and now it's just a matter of algebra. That becomes negative 1/3 plus 2/3 plus 4. So it's 4 and a 1/3 in front, which gives you 13/3.